Chapter 3, Section 2, Question 1. Functions and relations, domains and ranges. In Chapter 3, Section 1, we graphed out parabolas, and that was a function because it passes the vertical line test. So every point on this function only hits a vertical line once. But we also graphed out a sideways parabola. That is a relation because it would hit a vertical line twice. All it has to do is hit a vertical line more than once, just one time. Bam. It is no longer a function, it is now a relation. Domains and ranges. The domains have to do with your x's, the ranges have to do with your y's. So we're going to determine whether or not each of these is a function or a relation. Now it says determine if the relation. All of these are relations because they're related to each other. But only special ones are functions. So you do need to give us the best answer. So here we're going to take a look at just the x's. They're all different. They're all different. So therefore that is a function. Now let's take a look at just the x's. Hey, there's a repeat in there. That's not good. That makes this one a relation. In 121, you will be calling this, yes, a function and not a function. But for this level of math, we are using function and relation. Part B, we're going to find the domain and the range. I asked a student, how do you remember which is x and which is y? And a student said, x and y are in alphabetical order, domain and range are in alphabetical order. And I said, wonderful, that is a wonderful way of remembering it. Another student said, you always ask for domain first and range second, so that one's x and that one's y, which is absolutely true. All right, continuing on. The domain, you'll notice the squiggly braces on the outside. So these braces mean we're dealing with a set. And we want a set of only the x values, so 5, 4, and 7. But from chapter 1, we want them in order from least to greatest, so 4, 5, and 7. And we can quickly double check 3 ordered pairs, 3 x values, it's a function. The range, just the y's, 4, 3, and 3. There is a repeat, and I want them in order in least to greatest, but remember from chapter 1 that we don't write the repeats twice. And nobody cares over there that I have repeating y's until you get to 121, where later on they will be looking for, is it a one-to-one function, which means are all the x's unique and are all the y's unique. For right now, we are just going for is it a function or not. The domain, all the x's, 6, 2, 6. It's a set. Wow, that's horrible. Let me try that again. I want least to greatest, 2 and 6. Remember, we don't write that twice. The range, we have 8, 4, and 7. So 4, 7, and 8, least to greatest. There's 3 ordered pairs, but only 2 numbers in the domain. That means that something repeated, that's why it's a relation. For those of you who have the textbook, you can go to page 168, and 29 through 40 have a lot of function versus relation and domain versus range problems, where you can use it to see, does it pass the vertical line test, what the domain is, and what the range is. And also, they have a question about find all the x's where y is equal to 2, which will help you with reading a graph. Chapter 3, Section 2, questions 2 and 3. Now, not everyone has a textbook, so I put some of these together for you. We have, is this a function or a relation? And write the domain and range as sets. So here, is it a function? Does it pass the vertical line test? All the dots are sitting next to each other, not on top of each other. So it is a function. And then the domain and the range. The domain is our x's and the range is our y's. This has Because it's on a graph, it's very easy to go from least to greatest, -2, -1, 0, and 1. And then the range is also easy to go from least to greatest, -1, 0, 1, and 2. Here's another problem. Let's see, is it a function or relation? There are no dots sitting on top of each other. This is still a function. We're writing the domain and range as a set. The domain, the x values. Now be careful. Many students want to use 3. That's a y value. We need to look at the x values. So the corresponding x values are -1, 0, 1, and 2. Least to greatest, -1, 0, 1, and 2. And then the range, there's only a single number, 3, because they all line up. More points. There are 4 points. Are they sitting on top of each other? No, they are not. It is still a function. But this is to show you that those points do not need to be next to each other. We'll have to be careful about these domains. -6 and -4. But wait, there's more. 1 and 4. So sometimes they'll be above the x-axis and sometimes they'll be below. The range, starting at the bottom, -3 and -2. 3 and 4. Sometimes they'll be on the left and sometimes they'll be on the right. And they're all different. So it's a function with this domain and this range. The reason that we use the sets and the commas is because they're individual points. Oh no, take a look. That is no longer individual points. It's connected. The individual little point graphs are called discrete, and this is called a continuous graph because it continues. Many people completely ignore this part where it's connected because they just want to see the points because that's easier. That's because that's not going to help them get them to 121, the college class, which is what we're aiming you at. So, is this a function? Does it pass the vertical line test? Yes, it does. So this is a function. Now the domain, we actually learned about this in chapter 2. The domain goes from -2 to +2. It goes from -2 to +2. Solid dot on the left, solid dot on the right. Interval notation. The range, how far down to how far up? It goes from 0 to 2. It goes from 0 to 2. Remember that we're making the equal sign and connecting it to make those brackets. Now, let's take a look at this. I'm going to draw a box around this for the top and the bottom, and the left and the right. And it just barely fits in this rectangle here, and that will help us perhaps see -2 to +2 on the x's and 0 to +2 on the y's. Where is a function or relation? Does it pass the vertical line test? Right here, it only hits 1 point, but then it hits 2 points, 2 points, 2 points, 2 points, 2 points. No points. As long as it hits 2 points at least one time, it is a relation. And then our domain and range. If that made sense to you, to make the little box around here, this will help our eyeballs go straight up and down the lines, because a lot of people, their eyeballs get a little crooked when they're looking at it. So the domain on the x-axis goes from -2 to 1. And some people, their eyeballs curve and then they start here. So -2 to 1, solid dots on both sides. At this level of math, we're going to have solid dots on both sides for this. In 121, they might put an open circle here, or here, or here. The range goes from -5 to 1. It goes from -5 to 1. Is it a function? It doesn't hit it all, it hits only one time, and then it hits 2, 2, 2, 2, 2, 2, 2, 2, 1, nothing at all. As long as it hits in 2 spots on a vertical line, this is a relation. All right, and if we make our handy dandy box around this graph, it'll help our eyes to keep from curving with the curve of the graph so that we can read on the x-axis -3 to 3 and on the y-axis -2 to 2. -3 to 3 and -2 to 2. Some students are going to try and put in other numbers in between it. We don't want that because interval notation just has the left side and the right side, and that's it. Is it a function? Let's try it without the yardstick. 2 dots sitting on top of each other. It is a relation. Let's try it without the box around it. -3 on the left to +1 on the right. Don't curve your eyeballs up, go straight across. -4 to +5. Is it a function? Ooh, it's squiggly. But does any x have 2 different y's? No, it doesn't. It is a function. Now, if you need to draw a box around that, please do so. This is something that you're going to see on our quizzes, our homework, our tests, and also you'll see these in 121. This is a skill that a lot of 121 students struggle with. So we want to make sure you learn it now so that it'll be in place for 121. So the domain here goes from -3 to +3. That's on the x-axis. That's a lot easier to read. But then the range. Many students might go from -2 to 0, but hey, it goes all the way up here to +2, -2 to +2. Do make sure that these are pretty darn 90-degree brackets instead of, remember, some students were giving me, trying to make it parentheses or brackets, whichever one was correct. Don't make me choose. I will choose whichever grade is going to make it lower. So make sure that they're brackets. Is it a function? I have 2 points on top of each other, and over here I have 1, 2, 3, 4. Oh my gosh. But it really doesn't matter. As soon as I have more than one y value for any x value, it's a relation. Now, the domain. How far left does it go? Some people say it goes 2, but it goes to -2 because we're reading off of the x-axis, all the way over to 4. -2 to 4, -2 to 4, equal sign because it's a solid dot, and connect. Equal sign because it's a solid dot, and connect. The range, how low does it go? Some people say till 1, but you have to read off the y-axis. So -1, all the way up to the top at 5. -1 to 5. Nice square brackets. Nice square brackets. Ta-da! Is it a function? It passes the vertical line test. Now some students say, hey, I have like this arrow, it touches 1, 2, 3 times. The arrow implies that it goes on forever in both directions. That is from geometry. So this is still a function. Remember, our interval notation goes all the way to the left and all the way to the right. So this one, it goes all the way to -infinity and all the way to +infinity, which means it hits everything and it doesn't stop in the middle. Range, how far down does it go? It goes down forever to -infinity. It goes up forever to +infinity. The range is also -infinity to +infinity. Is it a function? This time it's not a function because it has this little woohoo. It has that little zigzag in there. That makes it a relation. But let's take a look at the domain. It goes forever and forever. How far down for the range? Forever. And how far up? Forever. Hey, this is going to be negative infinity to positive infinity. I hope you've been working on drawing your infinity symbols, because some of my students have to stop. Each time they have to write one of those, turn it sideways, draw the number 8, turn it back, put a comma, turn it sideways, write the number 8. But hey, if that's what you need to be successful, you do that. Now, it says don't erase because if you were in class with me, we would be doing these together as a class. But I thought that it was worth it to go over each of these slides because this is what we would be doing if we were in class together, is practicing so many of these, because this skill here, finding out is it a function or is it a relation, what is the domain, what is the range, it is a skill that many students struggle with even in the college classes. So I want to make sure this is here for you. So as we go across, it passes the vertical line test. It is a function. All right, I'm going to be a graph here, look like that. How far does it go? It goes all the way down to negative infinity and it goes all the way up to positive infinity, but wait, how low does it go for our range? Our domain is from negative infinity to positive infinity, but our range, it starts here at 0 and it goes up. So it starts at 0 and it is a solid equal dot at 0, and then from there it goes up to infinity. That's different. That's a parabola from back in chapter 3, section 1 when we were graphing. Is it a function? Note the extra points. I put eyeballs on my happy parabola. It is no longer a function because here I have 2 points sitting on top of each other. It is now a relation. Let's take a look at the domain. I have a parabola. It goes forever this way. It goes forever this way. It goes from negative infinity to positive infinity. That is our domain, negative infinity to positive infinity. The range, the lowest point is still at 0, and it goes up. It starts off at 0. It is equal to 0, and then it goes to infinity and beyond. Sorry about the don't erase again. Over here we have another parabola. It goes from negative, it's a function. It goes from negative infinity to positive infinity. Yay, that's its domain. Negative infinity to positive infinity. The range, right here, starts at 1 and then goes up. So it starts at 1. It is equal to 1. We make a nice straight bracket, and then it goes till infinity. Ta-da! Do you know that we're going to be doing functions and parabolas as functions a lot? It's a parabola. Parabolas are functions as long as they're opening either up or down. Hopefully you know that the domain is going to be from negative infinity to positive infinity. It goes all the way to the left and all the way to the right. That's what those arrows are talking about, the range. This point is now at negative 2. Be careful, a lot of students accidentally say negative 3 because they see negative 3 right there. But this is a y value. Why is it a y value? Because it's the range. So we have from negative 2 to infinity. It is the sideways parabola from back in 3.1. Therefore, it is a relation. Now, the domain does not go from negative infinity to positive infinity anymore. It goes from this point to infinity. This point is not at 2 because the domain refers to the x values. It goes from 4 to infinity. Infinity is so large, it always gets a parentheses. 4 has a solid dot, so it gets a little equal sign connected to make a bracket. Now let's look at the range. How low does it go? Negative infinity to positive infinity. Is it a function? Yes, it is. It passes the vertical line test, so it is a function. The domain goes forever that way and forever that way. It is from negative infinity to positive infinity. But the range is only one number. We had one like that earlier. We cannot write it in interval notation because interval notation says from here to here. This is only a single number. We can't write it in interval notation. We have to write it as the set of the only number that works, which is 4. I hope you haven't been fast forwarding through this. You might miss this. Is it a function? Let's take our vertical line test. It's fine, it's fine, it's fine. Oh my gosh, it just failed big time. Everywhere there are an infinite number of points sitting on top of each other. That is a relation. The domain, gosh, just like last question, the domain doesn't go from somewhere to somewhere else. It only encompasses a single number, -2, which means that we have to write it as a set of that one number. That's why you'll see the instructions on this say, write it in any valid format. This is the only valid format you can do for just the number 2. And then the range, how low does it go to how high does it go? It goes from negative infinity to positive infinity. Chapter 3, Section 2, Question 4. Function notation. You may not have seen function notation before. This is function notation. So the F stands for function, but later on we'll change it to G of X, H of X, K of X, something else. We'll also change the X's into different letters, so you might later on see something like J of M. And that's how we read this, is F of X. Evaluate each function at the indicated value. We are going to use plug, work, answer. We've been doing that since chapter 1. It is still here. So, question on the left-hand side is f of 4 equals, plug it in, 4 squared plus 4 over 4 minus 4. Order of operations, you're going to do all the tops, you're going to do all the bottoms. You're going to get 16 plus 4 is 20, divided by 4 minus 4 is 0. Hey, a 0 in the denominator, that's bad, so therefore f of 4 equals undefined. Now, I want you to take a look. I simplified this until I got a single number on top and a single number on the bottom. Some students say, oh, I just looked at it and I already know it's undefined. That's lovely. I want to know, can you still do the order of operations from back in chapter 1 and get that? I am willing to let you do multiple steps so that you have plug, work, and answer. You can cut out some steps because in chapter 1, I didn't want you to cut out steps. Now, we're in chapter 3. I'm willing to let you guys slide a little bit on that. Over here, the question on the left-hand side of all these, plug, work, answer. We're going to plug in -3 squared plus -3. Notice how I'm having to use parentheses here. I didn't have to there. Here, I don't technically have to use parentheses. Plug, work, and answer. I want to see you plugging in. I don't want this to just be a -3. I don't want this to be a 9 yet. I want to see, can you plug into a formula? Plug, work, and answer. 9 minus 3 is 6. -3 minus 4 is -7. So, hey, that is the answer, but we often do not have the negative in the denominator, so usually put it in the very front or on the top. And that is your answer. And that is your answer. That is function notation. Chapter 3, Section 2, Question 5. The difference quotient. This is the difference quotient level 1, and it's to find the derivative of lines. Find f of a plus h minus f of a all over h. Ladies and gentlemen, this is actually the slope formula, which we'll be going over more later. So the slope formula is m is equal to y2 minus y1 over x2 minus x1. And that would be if I had 2 points on the line. But the thing is not everything is going to be a line. Eventually we're going to get things that aren't lines. And instead of x1 and x2, we're going to have a and a plus a small amount h. The y value is going to be your f of a and your f of a plus h. So if we plug into the slope formula, we will get f of a plus h minus f of a all over the x value minus the x value. These will cancel out, and that's how we got this formula. It's really the slope formula, but you don't have to know that. Frankly, you don't have to memorize this, because at this level of math, we're always going to give you this formula. We're also going to give you something in function notation. This is the equation of a line. Step 0, it is often a useful thing, since we just learned about function notation. F of x is 3x plus 2, so f of a, all the x's became a's. So this x becomes an a. F of a plus h, all the x's become a plus h. So this x becomes a plus h. And then the formula says f of a plus h minus f of a all over h. Hey, I have plugged it in. Now notice, this had parentheses, so when I plugged it in, I put brackets around it. This has parentheses, so when I plugged it in, I put brackets around it. Remember from previous chapters? With parentheses and brackets, without parentheses and brackets, then you can add and subtract. So here we're going to use the distributive property. We get 3a plus 3h plus 2. Be careful, I've had some students get 6 because they accidentally distribute. This tells you to stop. Now I have a negative times 3a and a negative times a 2. Still all over h, because we cannot have the amazing disappearing reappearing denominator. The h is here until it gets canceled out, which will happen later. The next step after we multiply is to combine like terms. That's your adding and subtracting. I want to know, can you plug in? Do you know what it means to multiply? Do you know what it means to combine like terms, which is adding and subtracting? And it has a note here that anything that doesn't have an h should cancel. This is a 3a. It doesn't have an h. There is a minus 3a. They will cancel. If it helps you to cancel them out like that physically, go for it. That has an h and there isn't saying to cancel out with it. That's a plus 2 and a minus 2. If it helps you to cancel them out, that's great. If it doesn't help you, you don't have to do that. We have what's left, 3h over h. A lot of students don't want to write this and they'll lose half credit. They want to cancel it out here. But I want to know, do you know the difference between combining like terms and reducing? Because if you're doing it all in one big step, you don't know when to stop. I need you to know that this, from here to here, we are combining like terms, and now from here to the answer, we are reducing this fraction, which will give you 3, which is the answer. I want to see all 4 steps here. If you want to make this one and have a 5th step, that's fine. So this is a wonderful step 0, and it will help you to put the a's and h's into that formula, because that is the formula we're using. This helps you on smaller versions of function notation. And if you think about it, I told you at the beginning that this was the formula to find the slope. If you know about y equals mx plus b, f of x is also known as y. Here is your mx plus b. The m is your slope. The slope is 3. The slope is 3. We could have figured out the answer simply by looking at it. Now, if that is all you can do is look at it and say the slope is 3, Mrs. Jordan, then you write down 3 and I will give you half credit for understanding that this is supposed to get you a slope of 3. But half credit is a 50%, and a 50% is an F, and you're not going for an F. No one should be trying for an F. You should be trying for full credit, which is plug, work, and answer. Plugging in, multiplying, combining like terms, and reducing. That's what I need for full credit.